The good news is that we have some outstanding people doing that. Our final guest in this segment is Dr. Gloria Post. Dr. Post is a research scientist and toxicologist and in DEP's Division of Science and Research. She is considered and well known as a national expert on the subject of PFAS and other emerging contaminants. And she currently serves and has served on a number of US EPA and National Academy of Sciences advisory panels and committees. She's a member of New Jersey's Drinking Water Quality Institute, and she also represents DEP on the New Jersey Governor's Council for Prevention of Developmental Disabilities. It's truly an honor for me and for all of us, I think, to have her with us tonight. Gloria, welcome. Take it away.
Hi, can everybody hear me?
Yes.
Thank you. So I have quite a lot of information, but Vicki has told me that the PowerPoints will be shared. So if I go over some of the information on the slides kind of quickly, I think you'll be able to have the PowerPoint later to look at it in more detail if you're interested. I'm going to talk about emerging contaminants. I'm going to give an overview. I'm really going to focus on PFAS and talk a little bit about some other contaminants, general information, and New Jersey's actions to address these in drinking water. So just to start, and some of this was said in the earlier presentations, there's federal drinking water standards, but really there were very few prior to the 1980s. Most of them are since the 1980s. At that time in the 1980s, a study that DEP conducted found volatile organics in New Jersey waters. It's hard to believe that VOCs were considered the emerging contaminants of the time, but at that time there were no federal standards for them. So in response to this finding, and New Jersey's highly industrialized compared to other states, as we all know, the New Jersey legislature passed amendments to the New Jersey Safe Drinking Water Act that require development of MCL's drinking water standards, maximum contaminant levels, for a list of contaminants in the law and additional contaminants of concern in the future. The amendments also established the New Jersey Drinking Water Quality Institute, which is an advisory body that recommends MCLs to DEP. Most of the members are external to state government appointed by the Governor, Assembly, and the Senate. And there's also members from DEP, which I am one of the three of those, and the Department of Health. After we recommend the MCLs, our commissioner decides whether or not to propose them as regulations. So starting in the 1980s up till now, the Drinking Water Quality Institute and DEP have evaluated many different types of drinking water contaminants, and we have been and continue to be a leader in evaluating and regulating emerging drinking water contaminants.
Gloria, your slides are not advancing. I just wanted to mention.
I just advanced. It didn't advance.
No.
Hold on. Sorry.
Okay.
I may have to. Is it advanced now?
No. Okay. Okay. Now you're on your third slide.
I'm on.
One is what are
right.
Yeah. Good.
So I'm gonna leave it like this and not full screen because is that okay?
Sure.
Okay. So you saw the second slide, or no? Anyway.
We did not see that.
Oh,
but you've summarized it, so
okay. Sorry about that.
You can move it.
Okay,
there you go.
So most people or everyone has probably heard about PFAS, per and polyfluoroalkyl substances. They're a group of thousands of manufactured compounds that have at least one totally fluorinated carbon atom. They've been made. They're not natural. They're manufactured, and they've been made for over 70 years. Because of their structure, they repel oil and water, and they're both repel oil and water, and they're also very water soluble. And also because of the carbon fluorine bond, it's so strong that they resist chemical reactions and resist high heat. So because of these properties that I just mentioned, they're very useful commercially and industrially, but on the negative side, they never break down in the environment really, and that's why they're called forever chemicals. Many of them have little or no health effects data, and many are not detected by routine lab methods. Initially, the focus was on what we call long-chain perfluoroalkyl acids, or PFAS, and these are probably the ones most of you have heard about. These are ones that have a totally fluorinated carbon chain, and then they have an acidic group, either a carboxylate or a sulfonate. PFOA has 8 carbons, and it's a carboxylate. PFNA has 9 carbons. It's the same as PFOA with 1 more carbon. PFAS has 8 carbons, and it's a sulfonate. And then there's other ones with 4, 5, 6, 7, 8, 9, 12, 13 carbons that have the same structure, just a different carbon chain length. The long chain PFAS and PFAS in general are generally more bioaccumulative and toxic than the short chain ones. They stay in the body longer. Many of these have quite a bit of health effects data and they were the first group to be included in standard lab methods. For the long chain PFAS, their use in the US has ended, but as I said, they will persist in the environment indefinitely. There's 4 long chain PFAS that are shown here in this box, the 3 that are above, and also PFH excess with 6 carbons that are detected in the blood of almost all US residents. So at this time now, we've moved on, and many other types of PFAS, including replacements and short chain PFAS, are also of concern. But this is the first group and the most well-studied group. So why are these chemicals so concerning when they're found in drinking water? Why is there such a big issue about PFAS in drinking water? They're found widely in drinking water. They never break down. The long chain ones have long human half-lives, meaning how long it takes to eliminate half from the body, several years, approximately 2 to more than 8 years. So they build up in the body as we keep being exposed. And if we stop being exposed, like if we have elevated levels from a drinking water contamination, then that is stopped. It takes years, many years, to rid the body of the burden, the body burden. They cause many different types of toxicity in lab animals, and they're linked very low exposures, the exposure levels that we have in the general population, even without contaminated water, is linked to multiple human health effects. As far as drinking water specifically, there's many ways we're exposed to PFAS, but low drinking water levels, well, if that's our drinking water source and we drink it regularly, we get greater exposure from the low drinking water levels than from the other sources that everybody's exposed to, such as food and consumer products. This is shown here, up here in the bar graph. The light orange is the level of PFOA on average in the blood of a US resident. So the dark blue is the contribution if we have an average rate of drinking water, and the yellow is a higher rate of drinking water ingestion every day that we would assume, an upper bound. But basically you can see at 20 parts per trillion, 20 nanograms per liter with average consumption, we double our exposure. So even low levels in drinking water will give us a lot of exposure compared to the other sources that we all have. So this is why they're so different, really. This is like the bottom line. Other persistent bioaccumulative and toxic chemicals like PCBs and dioxins, those are the classic ones. They're not found in drinking water. They're found in fish. They bind to sediments. They're not water soluble. We get exposed from fish and from fat in our diet from cheese and meat and things like that, but not drinking water. That's why PFAS are so different. They're PVT chemicals that are prevalent in drinking water. Also, infants have higher exposures, and infants are susceptible to the toxic effects, especially breastfed infants in general, and also when drinking water is contaminated. This graph over here comes from the Minnesota Department of Health. They considered infant exposure in developing their drinking water standards at around, well, this is 1 year of age, but the breastfed infant has like multiples higher exposure than when they were born. At birth, it's similar to what their mothers have, and then it goes way, way up because of the amount of breast milk infants drink, and also the PFAS accumulate in the breast milk. So all of these factors indicate the need to minimize our exposure from drinking water. This is a summary of the major health effects of PFOA, PFAS, and PFNA. I really don't have time to read all of this, but the first part is lab animal studies. You can see all different types of effects that are found, including tumors for PFOA and PFAS. PFNA has not been studied to see if it causes tumors in animals. In humans, the ones that are listed are the major effects, the most well-established effects in the general population or in communities with contaminated drinking water. And again, the cancer, testicular, and kidney refers specifically to PFOA. PFAS have been used as processing aids to make fluoropolymer plastics used in nonstick cookware. They're used in the manufacturing process. They're really not in the final product. Teflon or other products like that are not, well, they're polymers, they're not, but PFOA is not, was used to make it. It's not at high levels in the final non-stick product. Also, the water and stain resistant coatings for carpets and upholstery, waterproof breathable clothing, grease-proof food packaging, such as French fry containers and other things, paper that's grease-proof like that, waxes such as ski waxes, polishes, paints, adhesives, cosmetics and personal care products, and aqueous film forming foams, or it's a type of firefighting foam, is really a major source of contamination. In drinking water, PFAS can come from industrial facilities, large or small, where they're made, or if they're used to coat fabric at a small facility. Wastewater treatment plants from the wastewater discharge, and also in the sludge or biosolids that are applied to agricultural land and crops and livestock could be contaminated. Leachate from landfills where products or waste with PFAS are disposed, and the firefighting foam, AFFF. It's a type of firefighting foam specifically used for petroleum fires. So it's where fires were put out, of course, but also when fire departments used it for training, and at airports and military bases, a tremendous amount was used in training. This map shows the military, the Department of Defense tested all the sites where it could have possibly been used to find out what the situation was. And this is a map of all the sites, military sites, where PFAS from firefighting foam had been found at the time. One thing I want to mention specifically about PFAS, when it's discharged from manufacturing facilities, it can go into, into a river or a surface water body or onto the ground and go to groundwater. But when things like PFOA, PFNA, or PFAS are emitted into the air, they can travel a distance, like, for example, 15 or 20 miles, and then go on to deposit onto the soil. And since they don't bind to soil, with precipitation, they leach through the soil and contaminate the groundwater distances away, like 10 or 20 miles away. That's different than most other chemicals. So now I'm just, okay. I hope you don't mind if I take a couple more minutes. I'll try to get through this as quickly as I can. But New Jersey first found out really about PFOA in groundwater in 2004 at the DuPont, now Chemours facility in Chambers Works facility. Then in 2006, we learned that it was in tap water and supply wells of a nearby public water system, and found in private wells nearby a little after that. This is one of the early maps in the bottom right. I've been working at DEP on drinking water contaminants since 1986, and there was quite a lot of expertise on drinking water because of the law that was passed in all different areas of expertise. Quite a few people from New Jersey DEP and the Drinking Water Quality Institute recognized PFOA and PFAS as different and of concern when we found out about this. At this time, they were not well known. Only 2 other states were looking at them, not like now. They didn't know what we were talking about. No one knew about it. But we had seen so many types of drinking water contaminants over the years that we knew they were very different for the reasons I mentioned earlier, because they're PBT drinking water contaminants. The first actions were initial actions were 2 statewide occurrence studies and the development of drinking water guidance of 40 parts per trillion at the request of the affected water system. It was Penn's Grove water system, and now it's part of New Jersey American. It was not at that time. That guidance was much lower than other states' guidance at the time, and it was published in a scientific journal in 2009. The 2 occurrence studies, the 2006 one, the first one, 20 statewide, all over the state. These were the first statewide PFAS occurrence studies in the nation. 23 water systems just for PFOA and PFAS, the first one. The second one was 31 systems for 10 PFAS. The reporting levels were 4 to 5 parts per trillion. We found multiple PFAS in many systems, PFOA most frequently in about 60%, PFAS in about 30%. And PFNA, which really no one knew anything about at the time, including us, we found in Paulsboro at the highest level report. When we researched it, it was higher than anywhere else reported in drinking water in the world at the time. We also found it in other public and private wells around the same area, and extremely sky-high levels in the Delaware River water, and also in the fish, just starting right around there, but not upstream. The source was identified as Solvay Specialty Polymers in West Deptford, and we learned that they had been releasing tons per year to the air and water, a large amount, for more than 20 years. They stopped using PFNA and PFOA in 2010 and now they were using and then kept using alternative PFAS, other ones, after they stopped using PFNA and PFOA. The UCMR, the EPA study that they do every 5 years, that was mentioned earlier by Pam. So the reporting levels were much higher when they looked for PFAS than in the New Jersey studies, 20 and 40 instead of 4 and 5. But it allowed us to compare New Jersey data to US national data on a consistent basis. So I'm just going to focus on the first 2, PFOA and PFNA. You can see that the occurrence was much higher in New Jersey, 11 versus 2% and 2 versus 0.2% than in other parts of the US. The PFNA was in around the area I just mentioned, Gloucester County area, and PFOA across the state. UCMR, it was mentioned already, now EPA is doing UCMR 5 for 20 PFAS with low reporting levels, and more water systems, even smaller ones than were included earlier will be included. So we'll get a lot of information. As far as regulation in New Jersey, in 2014, the commissioner of New Jersey, DEP's commissioner, asked the Drinking Water Quality Institute to develop MCL recommendations for PFNA, PFOA, and PFAS. And we did do that. These were adopted. PFNA in 2018, 13 parts per trillion. That was actually the first MCL in the entire US for any PFAS. PFOA and PFAS 14 and 13 were adopted in 2020. At the same time, the MCLs were adopted as groundwater quality standards. The 3 of them were added to the New Jersey Hazardous Substances List, and they were also added to the Private Well Testing Act. That's a law in New Jersey, a New Jersey law that requires private well testing of a list of contaminants when a home is sold for informational purposes, and also the landlord has to test at rental properties and inform the tenant. So they were added to that as well. Really quick, I just wanted to show the factors that we consider in developing MCLs. This is what we've been doing for all contaminants since the 80s. The health-based MCL is the goal. It's what EPA calls the MCLG. We call it the health-based MCL. Then we look at the analytical level that drinking water laboratories can reliably measure to, and also if treatment removal, the capabilities. If the analytical level was higher than the health-based level, then the regulatory MCL has to be set higher, same with treatment. But in the case of the PFAS, analytical and treatment their limitations weren't a limiting factor. So the MCLs are set at the health-based levels. That's what we want, but sometimes we can't do that. As far as MCL violations so far, it's the community water systems and the non-transient non-community water systems are required to monitor. There's 1144 we're submitting results, and of those 6.8% violated one or more of the MCLs. It's based on the running annual average of 4 quarterly results, and some or quite a few New Jersey water systems addressed PFAS prior to they were monitoring and they knew this was coming, and they took action to reduce levels before the MCLs were adopted. So they avoided violations. So those ones that would have violated if they hadn't done something earlier or not counted here, they didn't violate. But there were more that exceeded the MCLs to begin with, is what I'm trying to say. Okay, now we're up to really current information. The EPA proposed MCLs for PFAS in March, and they had a 60-day public comment period, and it ended today. The comments are going online on regulations.gov. There's a lot. They state that they plan to finalize it in the end of this year or early next year. If these are finalized, they will be the first federal MCLs for any new contaminant since the 1990s. That's a really big deal. If the health-based goals for PFOA and PFAS are 0. They are classified by EPA as likely human carcinogens, and EPA sets the goal as 0 for likely and known human carcinogens. The enforceable proposed MCLs are set at 4, which is their analytical minimum reporting level. And these are much lower than their earlier health advisories of 70 nanograms per liter for PFOA and PFAS, which New Jersey and other states did not think were health protective. The 70 meant many other states adopted lower numbers, just like New Jersey did after we did. They also are proposing 4 other PFAS to be regulated as a mixture. They're listed on the slide here. And they propose to use a hazard index approach based on assumed additive toxicity. EPA is required to do a cost benefit analysis for their regulations. New Jersey is not required to do that. And in their analysis, the benefits of the health risk reduction will exceed the costs of monitoring and treatment. Okay. Related to this, before they proposed this rule, they came out with technical documents to support it and risk assessments and interim health advisories that were very stringent. And the commissioner of DEP asked the Drinking Water Quality Institute basically to reevaluate the health effects data to see if it supports health-based numbers lower than our current analytical levels of 6 for PFOA and 4 for PFAS. The Drinking Water Quality Institute Health Effects Subcommittee did a very detailed review and concluded that health-based MCLs that are lower than these values are supported by current science. And now the other 2 committees, the analytical committee, the testing subcommittee, it's called, and the treatment subcommittee are evaluating whether we can lower our analytical levels and if treatment can meet them, to see if basically we could have lower MCLs in New Jersey. I know I just want to take 1 minute to talk about this because even though it's over this, I wanted to talk about alternative PFAS used at Solvay's West Deptford facility, because this facility's in the area that your group, it's in one of your counties, and this is really cutting edge stuff that is really interesting, and it's where a lot shows where PFAS is going and how complicated it is. So as I said, PFOA and PFNA were phased out, the use was phased out there. But now we know that 2 types of really unique to Solvay, and actually, as far as I know, only they may be used in Europe by Solvay, but I think they're only used in the US or only used in New Jersey. That's the only place in the US they were used. They used them before and after they phased out PFNA and PFOA. We now know they discharged we recently learned, it's 2019, that a large amount was discharged for many years, and they have stopped using them, I think last year, I think it was. This has a very long name, and it's I'm not reading it to you, but it's CLPFPECAs. We did a study, my colleagues did a study with the research chemists from the EPA Office of Research and Development. They're really the world's top experts on analyzing PFAS. They use non-target analysis. That means they can figure out what's there with no standard to compare it to. And they found these CLPFPECAs in many different types of media around Solvay soil, groundwater, sediment, surface water, including private wells. It was published in Science. I'm not one of the authors, but that's a really, really big deal to get something published in Science. And there's another type called dicarboxylic acids that's been found in groundwater monitoring by Solvay. In 2019, there was a legal directive that DEP had a legal directive that companies that used PFAS in New Jersey had to supply a lot of information to DEP. And that's when we found out that both of these types of alternatives are equally or more toxic than PFNA and PFOA. There really wasn't, they had these studies. We didn't know there were any studies, and then we found out there were these studies and they're really just as toxic in rats or more than the ones that were phased out. Also, there was a human worker study that actually we found out about because Consumer Reports magazine, a reporter, did a Freedom of Information Act to ask EPA for information on these chemicals, and they obtained this report, and we didn't even know. But there were in Europe, in Italy, the workers, they did a study, that's where it's made. The half-life is several years, the same as PFOA and PFNA, and it was associated with a whole laundry list of human health effects in the workers, which I have here. We developed an interim groundwater criteria for the CLPFP ECAs in 2 nanograms per liter, and we're working on one for the second type now. So this is my small bit of information on other emerging contaminants that we're working on or have worked on recently in New Jersey, drinking water contaminants. 1,2,3-trichloropropane. It's a very potent carcinogen in lab animals, unusually so, very genotoxic. It's mutagenic. It forms DNA adducts. It reacts with DNA, genetic damage and mutations. It was formerly used in pesticides, specifically fumigants supplied to agricultural land, also industrially. We adopted an MCL of 30 nanograms per liter, 0.03 parts per billion in 2018, and also added it to the Private Well Testing Act. 1,4-dioxane's another one. It's very water soluble. It's hard to get out of water. Classified as likely to be carcinogenic to humans by New Jersey and EPA. In the UCMR study, it was found more frequently in New Jersey than nationally. There was recently a situation in the Delaware River where it was found downstream, and it was traced upstream to discharge into the Lehigh River from a wastewater treatment plant in Allentown, Pennsylvania. But the ironic part, at least in my opinion, it's kind of ironic. The waste was sent upstream to Pennsylvania by a company from West Deptford, and then it was going down the whole Delaware River and contaminating all the drinking water intakes all the way down. But anyway, the Drinking Water Quality Institute recommended an MCL of 0.33 parts per billion, and it's been accepted by the commissioner, and DEP is going to start the process, which is lengthy, of proposing an MCL for dioxane. Lastly, cyanotoxins. These are the toxins that there's many different types produced by harmful algal blooms or HABs that form in water bodies. Exposure can be either through, if there's a HAB in a recreationally used a lake or something where people swim recreational, and if it's a water body used as a drinking water intake, it can get into drinking water. The HABs typically persist for days to weeks, and for that reason, drinking water guidelines are based on short-term exposure, not chronic exposure like other MCLs. The Drinking Water Quality Institute is currently evaluating potential regulatory approaches at the request of the commissioner. So that's my last slide. Please feel free to contact me and with any questions. I put these extra slides with all these links and things for when the PowerPoint's posted, so you'll have all of this information. Thank you so much. I'm sorry that I went over the intended time.
Gloria, that was fabulous. Thank you.
Well, it was supposed to be done at 8:30, so I didn't see.
Well, I think you've given us just a tremendous amount of information in a way translated for us in a way that we can use it.
Yeah,
and I absolutely want to thank you too for those last few slides that include all of the additional information and links to